I'll do my best to not look too tired. I recently went on a shopping spree on Aliexpress, which in my case means spending a total of $6.39 on 4 items. And it wasn't even like I needed any of these items really badly. It was just anniversary of Aliexpress and I got a coupon code for $1.60, so I just went for it. Anyway though, one of the items was so goddamn intriguing I just had to get it. There was no way around it. So basically it's a miniature-sized car stereo with remote control and about every single functionality you can wish for crammed into one single microcontroller. The only drawback is it has no touchscreen. Sorry, I'm a little ridiculous today. But the really important bit is that the entire thing, including remote control, only cost $2.58 on Aliexpress directly from China. Now today I'm gonna show you all the features this ridiculous little thing has, as well as test the audio quality to see if it's any good, which, if the price is anything to go by, should definitely not be the case. With that said, let the unboxing, or rather unbagging, commence. Now spoiler alert, I did already try it out beforehand just to see how and if it actually works, so the packaging isn't 100% original anymore, but then again, it's just a Ziploc bag. So what you get is the miniature radio, a bunch of wires, and the remote control. So the radio itself, it's just a little bit over 4 inch in size, and it's really cute. So what this thing can do is you've got a USB port to plug in your USB drive, a SD card slot to put in an SD card obviously, an aux in, the radio, and obviously Bluetooth, which is quite a bit, and it's all crammed into this tiny little microcontroller on the back here. The rest is only connections for wires. So that's that. Then the wires you get are not very much actually. You get one little red antenna wire. You need to solder this into this little plated through hole on the circuit board. Then you get the power wire and the audio out. That's all. Those just plug into the circuit board here and here, and it's basically ready to go. Then you've got these little plastic plugs to plug up the screw mounting holes, and that's it. Though before I put everything together to get it up and running, let's take a closer look at the circuit board itself. Now, even though you already kind of know what it looks like by now, here's a close-up of the front with all the buttons. First off, we've obviously got a USB port on the right and a small LED display to the left with the infrared receiver tucked right next to it, and the all-managing microcontroller in close proximity. Down here we've got a small quartz crystal thingy and the antenna for the Bluetooth. This thing here is a generic 7805 voltage regulator, which means you can power the board with anything between 6 and 35 volts DC. On the underside of the board we've got the SD card slot and an audio jack for the auxiliary input, as well as a bunch of clicky push buttons. The small plated through hole where you need to solder the antenna to sits behind the display with ANT written underneath, so you can definitely not miss it. One thing I personally find quite interesting is that the microcontroller isn't actually one of these anonymous resin blob on circuit board chips you used to find in super cheap electronics like this, but a real discrete component with even laser engraved markings on top that's been physically soldered to the circuit board. Well, that's pretty much everything there is to say about the stereo itself. The remote control is about everything you can expect for the money. It's incredibly light, weighing not even 10 grams, and very bendy. But guess what? It works just fine. Down here we've got the battery compartment, and even though it asks for a CR2025 lithium cell, it contents itself with a CR2016 because I have nothing else handy right now. As you can see on camera from the faint blue flashing of the infrared LED, it works nonetheless. I just soldered the antenna wire to the board as well as an audio jack to the output, even though admittedly I have no idea which one of these three wires is the right and which one's the left audio. I just know the middle one's ground. Whatever, the output from this board is standard line level, so you can drive most headphones from it no problem. To power it, I'm going to use a 3S lithium-ion battery pack I built in a previous video. If you didn't watch that one, the link's in the corner up here. And if you're one of the few people who've watched that video and you're wondering why the hell is it green now, well, I somehow managed to blow up the BMS, so I had to shrink wrap it in a different bottle. And to make the audio actually audible, I'm going to use this old school pair of computer speakers with a standard TRS audio plug on the end, which I'm just going to plug into the audio jack. So now the only thing I need to do is plug in the power and we're up and running. So on first power on, it always defaults to Bluetooth, and when I click on mode here on the remote or on the thing itself, it's going to go to radio, and unfortunately I need to turn down the volume for copyright reasons. I'm going to add royalty-free music later on while editing. So now you can switch to the next program with these buttons here. We can go to program 3 or 4. With these two buttons here, it's going to scroll through all available radio stations, and if you click scan on the thing itself, it's going to scan all the frequencies and assign them to a different number between 1 and 22. So now you can... No, why? It's paused. If you long press this, now it's going to scan, and once it's done you can literally type in which station you want to hear with these numbers here, and it's gonna take you to the specific radio station. If I want to listen to number 18, and we're on 18, let me just... Well, yeah, that's station 18. Now 13. Now let's go to 5. And then you can change the volume with these buttons here. You can go up to 50 and down to 0, obviously. Well, whatever. Let's go to 30. And then we can mute it here. And it's like paused, it's just muted. Anyway, then we can power it off with the power button. Interestingly, there is only a power button on the remote control and not on the radio itself. Now if I click on mode again, it's going to switch to auxiliary input, and then I'll need a cable to connect any device with a standard headphone jack to the auxiliary input, and we'll be able to hear some music directly from the device. Now I can turn up the volume, and now if I go to music, there it is. Some nice royalty-free music. And we can skip to the next one. Ah, that's not very... What is going on? Ah, that's not exactly what it should sound like. What is that? Wait. That's slightly distorted. That's not exactly what it should sound like. Let's... Yeah. Not very impressed by the auxiliary input. Wait just a second, I'll just plug this directly into the speakers and then we can listen to it directly and you'll see the difference. No, there is no difference. Wow. Why is that? Oh, it's this thing here. That's interesting. Well, I've never done that before. I tested the radio and the USB drive, but I didn't test the auxiliary input, and it seems like either the audio got corrupted while I put it onto the SD card, or something's wrong with this device here. Whatever. Well, it seems like the distortion's been taking place inside this thing here or on the SD card, so it's probably not the fault of my nice little stereo here. Whatever. Let's go and unplug the auxiliary input and switch to... Yeah, well, only mode left is Bluetooth, so I'm just gonna let it on Bluetooth and plug in my USB drive here into the USB port. Then we'll be able to hear the music from the USB drive. Well, that's track 1. Just like with the radio, you can switch between the tracks. You can listen to track 5 or 47. Or 68, it's the last one. Well, yeah, that's it with this thing. As before, you can mute it here, and you can also pause it with this button here. You can pause and play. You can obviously change the volume. I don't know what this button here does. Oh, it's the repeat button. Yeah, this one does repeat. I've never tried this before. It does repeat. Actually, there it can repeat all or one track here with this button here. That's very interesting. Now I'm going to stop and unplug my USB drive. Now I'm going to try the SD card. Is it going to work? Yeah. Track 1. Track 2. 6. 34. So now we are on Bluetooth, and I'll switch on this thing here again. And actually pairing with Bluetooth is very easy. You just go on Bluetooth and search for device, and there it is, Bluetooth speaker. Let me just focus, Bluetooth speaker, and I go to Bluetooth speaker and match, and it's matched. Now we can go back and listen to some music. Here it goes over Bluetooth. Next track. Anyway, this is Bluetooth. It works just fine, as you can see. Pairing is very easy and seamless. Let's go back, and I believe we can pause. Yeah, we can pause Bluetooth with the remote and resume. Yep. We can stop. No. We can't stop Bluetooth, but we can obviously change the Bluetooth volume on the device. As usual, it's just a normal Bluetooth transfer. So one thing I didn't mention yet, you've also got an equalizer button, and you can switch between pop and rock and jazz, classical and cut, whatever that means, and normal. Pop, Let's just turn on the volume. It's just standard equalizer settings that are applied to the music inside this thing here. And now to determine whether the audio quality is actually any worse having been through this thing, we need a slightly different setup. After a little bit of research, I came across a free open source spectrum analyzer called Spec, which lets you visualize the quality of any audio file you like. So basically all we need now is an audio file that has undergone the dubious treatment by our cheap little car stereo to compare against the original one. Would be nice if it was that easy, because we do need a fairly good quality audio file to begin with, and as it turns out, none of the audio files you can download from the YouTube music library are actually good quality. To be more precise, MP3 files in general are way too compressed to serve as a scientific reference point in a comparison, since all frequencies above 20 kHz are basically cut off to save on memory. Now luckily I've still got a bunch of music tracks I made myself while playing around with this smartphone app called Splash Music and Beatmaker, and those are actually saved in the WAV format, which means they are uncompressed and exactly what we were looking for. Now if I go ahead and open up this one using Spec, you can see the spectrum reaches all the way up to 24 kHz, and even though we can't really hear these kinds of frequencies, I think it does make a difference in how you perceive the sound. Now unfortunately, creating the files for the comparison wasn't exactly as easy as I had hoped for, and since I don't really know how many of you are still watching at this point, I think I'm just gonna tell you what I did and show you the results afterwards. So basically what I did was connect this thing's audio output to the line in on a PC, which allowed me to directly record the analog signals sent by the car stereo to a WAV file, which on the other hand can be analyzed using Spec. And I also did a second version recording the playback on my phone using exactly the same technique, so that should give us about the same amount of noise and distortion due to re-recording an analog signal through a physical cable. Let's go to the results. Those are actually quite astonishing. While we do see quite a notable drop in quality between the original untouched file and my phone's playback literally being cropped down to 22 kHz and remarkably less dense throughout all frequencies, there seems to be almost no difference between my phone's playback and the output from our little car stereo. Considering the price difference between my phone and the cheap radio, I think that's actually really impressive. Also, keep in mind that they were both playing a file stored on an SD card, so there shouldn't be any other quality issues than the quality of the digital to analog converter itself. And before we answer the question from the beginning of the video, is this thing any good or not, I'll just shut up for a second to let you hear the difference. Well, to the naked ear, the bass is a little bit fuzzy, everything's just a little bit washed out, but as long as you're not an audiophile and you don't really care about having good quality audio, I think it's just fine. In the end, it obviously all comes down to the intended application. For example, using it as a car stereo like advertised, you won't really care that much about sound quality because over the noise of the engine you won't be able to hear that much anyways. Or you want to build a speaker system for your workshop, then part of the time you'll have hearing protection on with machines running. Now for a few things I didn't mention beforehand, I did forget to remove the protective film on the remote, which makes it actually look much uglier and cheaper than it actually looks. And then, if you're planning on using the radio on this thing more frequently than not at all, I think it would be a good idea to extend this dinky little cable with a normal extendable radio antenna. Anyway, at this point I'm finally going to leave you alone. If you're still around, thanks a lot for watching my stupid video of me talking. And as usual, links to everything I've talked about will be in the video description. You can leave a comment, that will be very appreciated, and I hope I'll see you very soon. Bye!